Good morning. Today we want to continue the example of partial fraction decomposition. And in our last video, we added two individual fractions together to get one fraction. Note the individual fractions were degree 0 over degree 1, and our fraction added together was degree 1 over degree 2. So today we want to figure out how we can reverse engineer the process and go backwards to figure out, when given a fraction, what fractions were added together. So let's take a different example. And I got this example from the Khan Academy because I thought it was particularly good. And in this example, I have x squared minus 2x minus 37 over x squared minus 3x minus 40. And before we do anything, our very first step must be to have the numerator be a lower degree than the denominator. That's a rule that we have to follow for every problem we do. In our example that we started with, notice that requirement was met, right? Degree 1 over degree 2. So I picked this problem because it reviews long division. So I'm going to do long division and ask myself how many times x squared goes into x squared, which is 1. And I'm going to multiply 1 by every term in the divisor. So x squared minus 3x minus 40. If I subtract, I get the x squareds will cancel. This is going to be x plus 3. So what we know is that our improper fraction is mathematically equivalent to 1 plus the quantity x plus 3 over x squared minus 3x minus 40. And what we want to do is break down this particular fraction and see if we can decompose it into its parts. Okay, so let's think about how that's going to work. Let's try to reverse engineer what we think happened. So I'm going to use my last example to sort of help. All right, in the last example, let's kind of look at the last example. What we noticed was that in the step before, the denominator was factored, right? And those factors were kind of useful because each number was over a factor. So what I'm going to do is I'm going to take my denominator and I'm going to factor it. So x plus 3, how does that factor? That's going to be what? X plus 5 times the quantity x minus 8, okay? And then I'm going to say to myself, okay, before that, what happened? Well, something over the first factor plus something over the second factor added together to get me that fraction. So I'm going to continue to decompose this and say that something over the first factor plus something else over the second factor is what was added together to get me this. Okay, now I'm using the letters A and B because they are commonly used in calculus. I have no idea what A is and I have no idea what B is. These are both unknowns, okay? So this is essentially the crux of my problem. I need to figure out what happened. What over x plus 5 plus what over x minus 8 adds together to give me x plus 3 over x plus 5 times x minus 8. And, you could probably play around with this and just trial and error figure this out. And I'm sure if you pause the video, you could try this on your own and you could probably figure this out. So I encourage you to do that if you want. But, some of you may say, I don't have the patience for that, right? A could be anything, B could be anything, X could be anything. There's too many unknowns. I want a better algorithm. And so I'm going to show you an algorithm for figuring this out. So what you're going to do is you're going to basically add A plus B. All right, so you're going to just pretend this is a regular addition by multiplying each fraction by its fancy one, just like you would in normal math. Okay, so you see what I'm doing? I'm just adding the fractions together like I normally would. Right, multiplying each fraction by its required fancy one. And then I'm going to say this is A times the quantity x minus 8 plus b times the quantity x plus 5 all over, I can now put these together, x minus 8 times x plus 5. Okay, so I'm just adding fractions like normal. But don't forget, this was all equal to x plus 3 over x plus 5 times x minus 8. Okay, so at this point, what do I know? I have two fractions that are equal to each other. Both of these fractions have the exact same denominator. All right, so what that means in math is that the numerators are equal. Okay, so I know that x plus 3 is equal to a times the quantity x minus 8 plus b times the quantity x plus 5. And my job now is to solve for a and b. Those are the things that are my mystery. Those are the things that I want to know. Now, my issue in this problem is I have one equation, but I technically have three unknowns, right? I don't know x, a, or b. So because I don't know x, and x is a variable, x can be anything. It can vary. So one of the tricks is make x a value that helps you solve for something else. And in this case, I'm going to let x equal -5 because I don't know what x equals. Why can't it equal -5? And by letting x equal -5 and plugging it back in, this is kind of cool, you're going to be able to solve for a. So -5 plus 3 equals a times -5 minus 8 plus b times -5 plus 5. See how cool that is, right? That's going to add to 0, eliminating b. I'm going to get -2 equals -13a divided by -13. And I'm going to get that a equals 2/13. So part of my mystery is solved. I know that a was 2/13, which is not something I personally would have been able to figure out on my own. That would have been kind of hard. So I think because a turned out to be a fraction, that would have not been easy to see. Now I'm going to do the same thing to solve for b, right? Again, x can be anything. I don't know what x is. It's a variable. So I'm going to now let x be 8. Okay, why not? I need to solve for b. So let x equal 8. And that's going to basically get rid of the a, right? That's going to go away and go to 0. And I get 11 equals 13b. And again, the b is equal to 11/13. So a and b are solved. My mystery is solved. I correctly reverse engineered the process. And I know that up here, this was, so this was, what was a? A was 2/13. So 2/13 would have gone there. And b was 11/13, would have gone here. And I have successfully decomposed my fraction. And if this were a calculus problem, right, I could integrate or find the integral of, don't forget about our 1 plus 2/13 over x plus 5 plus 11/13 over x minus 8. And that would be a very, very easy problem to do. Way easier than the original problem of x squared minus 2x minus 37 over x squared minus 3x minus 40.